Now, the different types of muscle. Okay, striated. Striated means that you have Z-lines. That's what striated means. Striated means that you have Z-lines in between things. Smooth muscle doesn't have Z-lines because it is in an electrical syncytium. It's more of an electrical syncytium, so you don't have Z-lines. So striated, you see, this is the same thing. Striation is sarcomeres. Striated, okay, non-striated means no Z-lines. No Z-lines means no sarcomeres. So saying striated is the same thing as saying striated means Z-lines means sarcomeres. Smooth muscle, non-striated, no Z-lines, no sarcomeres. If it's not organized in that way, it has gap junctions, which makes an electrical syncytium. That means it is fast. That means it is bidirectional. It means it is fast, and this means it is bidirectional. Now, in skeletal muscle, you have individual fibers innervated. And you might say, well, that seems inconvenient. Well, how about this? You go to lift up a glass, and let's say it wasn't an individual muscle being innervated. That would mean that your bicep would contract, and all of a sudden, let me reach for that glass. And it's not individually innervated. And your bicep contracts, and it goes, contract. You'll want striated muscles and skeletal muscles to be done individually because you don't want the whole of the skeletal muscle to contract simultaneously. That's called a seizure. If you had an electrical syncytium between all your skeletal muscles, you would be seizing right now. Smooth muscle, like the detrusor in the bladder, like the esophagus. We want a lot of this to be one electrical syncytium because we want the whole thing to contract at the same time. We don't want to just have a little bit of the bladder and a little bit of the bladder, a little bit of the bladder contract. We want the whole thing to contract and empty. The diaphragm, we want the whole diaphragm to contract. We don't want just a piece and a piece. But skeletal muscle, when I'm moving my finger, do I want an electrical syncytium with my left ankle? I don't want an electrical syncytium with my finger and my left ankle. I want individual muscle innervation. So in skeletal muscle, I want individual muscle innervation so I'm not having a seizure. I don't want the whole body contracting. The sarcolemma keeps separate. Lacks junctional complexes is again how you keep them separate. Skeletal muscle must be separately innervated so that you can have conscious control over just moving your pinky if you want to. If your skeletal muscle was one electrical syncytium with the rest of your skeletal muscle, that would mean I'd move my pinky and my right leg would go up. So we want them individually innervated. In the heart, we don't. We want a wave of contraction to go through from top to bottom so the blood can eject because the whole heart will contract. Your detrusor, your bladder, detrusor, your diaphragm, one wave of contraction. But in skeletal muscle, we want one muscle at a time. Now, back to the different types of muscle. Troponin binds to the calcium. This moves tropomyosin. It moves tropomyosin out of the way. And when tropomyosin is moved out of the way, then the myosin heads can attach and pull it along. Calmodulin, what a wonderful name that is. That's calcium modulation. Calcium modulation. Calmodulin. There's nothing else you need to know differently except it's a different protein. That's also why when you're looking for a myocardial infarction, we like to look for an elevated troponin level. Now, we have an extensive sarcoplasmic reticulum because we want to basically to lose and release calcium through the whole muscle. So the sarcoplasmic reticulum is how we deposit calcium through the T tubules. But in smooth muscle, we don't have to have the sarcoplasmic reticulum because it's in electrical syncytium. Because of the electrical syncytium, the wave of contraction can go through. When you have have to have each muscle group innervated separately. You've got to have a sarcoplasmic reticulum which can squirt calcium to the muscle group. When you have an electrical syncytium, you're not counting on calcium being deposited everywhere. You're counting on a wave of electricity going through these gap junctions through the whole electrical syncytium. Our final slide. The T-tubules form triads where you join up with the sarcoplasmic reticulum. The reason that the surface membrane lacks calcium channels is because you're not taking calcium in from outside the myofibril. You're not taking calcium in from the outside. You have a sarcoplasmic reticulum inside the sarcomere. So since you have a sarcoplasmic reticulum inside the sarcomere, you don't need to take calcium in from the outside. You're using the calcium within your sarcoplasmic reticulum. So you don't need the surface membrane calcium channels because you're having calcium that's contained and recycled within the muscle. Isn't that cool? Depolarize, then pumps pull it back into the sarcoplasmic reticulum. Depolarize, then pumps pull it back into the sarcoplasmic reticulum. I think that's very cool. In cardiac muscle, voltage-gated calcium channels are also what allow us to have the plateau phase, phase 2. The voltage-gated calcium channels is what allows us to have that plateau phase that makes us have this huge 200 millisecond activation potential. So you have voltage-gated calcium channels because that's the same thing as saying the heart has a longer action potential. The heart has voltage-gated calcium channels. The heart has a plateau phase. And skeletal muscle doesn't. You don't need T-tubules in smooth muscle because you have an electrical syncytium that has a simultaneous electrical spread throughout the smooth muscle. It's not a myofibril that's dependent upon T-tubules penetrating it and to deliver calcium. You don't need calcium in smooth muscle. You don't need calcium in smooth muscle. You have an electrical syncytium to deliver electricity through the whole muscle simultaneously. In skeletal muscle, you have triadic contacts going in two directions, a T-tubule going in two directions between two sarcoplasmic reticulums. In cardiac muscle, you don't need as much of that. You just have the T-tubules near the Z-lines depositing calcium inside. Well, skeletal muscle, the main thing is between the different muscles is that skeletal muscles have Z-lines, need T-tubules, and it needs the T-tubules to deliver calcium from the sarcoplasmic reticulum everywhere. If you can't deliver calcium to it, it can't contract because it's an individual fibril. Smooth muscle is all hooked up as one electrical syncytium. It doesn't have to have calcium tubuled in. It just spreads the wave of electricity through all the myocytes without the need for individual calcium deposition. When you have the muscles too close, there's no active force. When you have it too far back, there's not enough active force because it's been overstretched. You want to have it stretched moderately. So there's some passive stretching, and at the same time, you have maximum active stretching for ATP because you want the actin and myosin filaments to be touching to each other. And that's what allows for the maximum amount of force in skeletal muscles. Skeletal muscles are individually innervated because I don't want that wave of electricity to go through my whole body. I want it to stay in individual sarcomeres and myofibrils. The bladder, the diaphragm, the heart, I want to be an electrical syncytium that beats entirely. I hope you're having a great sense of accomplishment, and I hope that you're taking as little time as possible to master all this ordinary knowledge so you can get some new stuff and go on the next advance. Remember, this sort of stuff is not largely going to change. So if you learn it now and you make this energy investment now, an extra hour now, you're going to be good for the rest of this lifetime. I wish you well. Good luck.